Hi, my name is Lisa Klingler. I'm an educational consultant for the CAIU, and today we are going to be working with the CRA progression and really just focusing on the concrete representational models for addition and subtraction. So here we go. So like I said, we're working in CRA and really just focusing on the C today. And for this video, we're going to look at addition and subtraction. There are other videos that Jared Campbell created with the R and the A, and I suggest checking those out after looking at the concrete. So the first thing we want to do is to explain the tools that the students are going to be using for the concrete representations. And that is, we're going to be using base 10 blocks in order to represent this algorithm. So we have a 100 square, we have a 10 stick, and we also have ones. So these are the tools that we are going to use in order to represent our equation. So it's important that students understand what these tools are and that they're explicitly explained before we ask students to use them in an appropriate way. So we're going to look at the equation. It looks like I have 23 plus 42. So in order to model this equation, I'm going to first start with 23, and I can see that I have two 10s. So I'm going to put down two sticks here, two 10 sticks. And then I also have three ones. 1, 2, 3. My next number is 42. So looks like I have four 10s, and I have two ones. Now we know that when we are adding, we are putting together, so that's exactly what we're going to do here. I'm going to start with my ones, I'm going to put them together. Now in this case, I like to have it look just like the students are used to as they did in early numeracy, which is a 10 frame. So I'm going to set it up just like a 10 frame as it would look. And I'm also going to combine all of my 10s. Now the next question I'm going to ask is, can I make a 10? And looking at my ones here, it looks like I have 5. So the answer is no, I can't make a 10. Can I make 100? And the answer is no. Looks like I have 6, so I can't make 100. So I'm ready to add these numbers together. So it looks like I have 5 ones, and it looks like I have 6 10s, which is equal to 60. Okay. And I know that 60 plus 5 is equal to 65. So that is how you're going to represent a 2-digit by 2-digit addition problem. So let's go ahead and look at another problem. In this one, we have a 3-digit number, and we are adding to it a 2-digit number. So I'm going to use my base 10 blocks. Looks like I have 100. I have two 10s, and I have 5 ones. 1, 2, 3, 4, 5. I know some teachers like to use organizers for their base 10 blocks, and that's perfectly okay to have if you have students who need to have separate spaces as a way to scaffold, and if you feel like that can be then taken away, you can do that as well. So the next number here is 66, which is 6 10s and 6 ones. So again, I'm going to be adding, which means I'm putting together. So I'm going to put my 10s and my 10s together and my ones and my ones together. Okay. Now I'm going to go through and ask myself if I can exchange. So I'm going to start with my ones, and I'm going to say, do I have 10 ones that I can exchange? And the answer is yes. So I'm going to go ahead and exchange 10 ones for a 10 stick. And it looks like I have one left over. I'm going to ask the same question here for my 10s. And looks like I have 5 here and 4, which is 9, so the answer is no, and I have 100. So I am left with 100 plus 9 10s plus 1 1. And that is equal to 100 plus 90 plus 1 is 191. So that is how you represent a 3-digit with a 2-digit with regrouping. So next we're going to look at subtraction. So the next problem we're going to work on is 32 minus 18. So I'm going to first start with the 32, and looks like I already have my base 10 blocks ready to go. I have 3 10s. So 10, 20, 30, and I have 2 1s. And it looks like I have to subtract 18 from 32. So the first question I'm going to ask is, can I subtract 8 from 2 without getting a negative number? And the answer is no. So we're going to have to ungroup my 3 10s. And to ungroup, we're going to have to do some exchanging. So what I'm going to do in order to take away 8 from 2 is I'm going to exchange 1 10 stick for 10 ones. It's important to know that before doing this problem that students understand that this 10 stick is equal to 10 ones. And even if they have to line those ones up to see that correlation, it's important that they understand that those 10 ones are the same thing as a 10 stick. So I'm going to go ahead and do that exchange to ungroup my 3 10s. And so I have my exchange. I'm going to exchange my 10 stick for a 10 for 10 ones. And again, I'm going to go ahead and line it up just like a 10 frame so students can subitize this number easily. Okay. And now I'm going to say, can I take 1 10 from what is left over? And the answer is yes, which means at this point we are ready to subtract. So I'm going to take 8 1s. Okay, I'm going to take away 8 1s. So I have 1, 2, 3, 4, 5, 6, 7, 8. Taking away. And I'm taking 1 10 away from my 10s. Okay, and again, this is where an organizer might be nice so that they can see what they are taking away. So let's see what we have left. We have left is 4 1s and a 10 stick, which is 10. And I know that 10 plus 4 is equal to 14. And what I can always do is double check that I took 18 away. So I was supposed to subtract 18, which means I should have 18 in my discard pile here, which I have a 10 stick, 1, 2, 3, 4, 5, 6, 7, 8. And I know that 8 1s and 1 10 is equal to 18. So this is what I should have taken away, which is correct. And 14 plus 18 is equal to 32. All right, let's go ahead and do a problem with 3-digit numbers. So we're going to do this next one here, which is 432, and we are going to take from that 146. So I'm going to go ahead and set up my problem. I have 400. Okay, so it looks like I have 4 hundreds here. I have 3 10s. I'm actually going to move this down here. 3 10s and 2 1s. Okay, I'm going to ask myself, can I take 6 from 2 without getting a negative number? And the answer is no. So I'm going to have to ungroup and exchange some 10 ones for a 10 stick. So I'm going to exchange this 10 stick for 10 ones. Okay, so I'm going to put it in my discard pile here. I'm exchanging it for 10 ones. So 4, 5, 6, 7, 8, 9, 10. Perfect. Now I need to ask myself, can I take 4 10s from what is left over in my 10s pile? And the answer is no. So I need to then ungroup my hundreds in order to do that. So I'm going to take 100, put it in my discard, and exchange it for 10 10s, because we know that 10 of these is equal to 100. So it looks like it matches, and again, it's important for students to see that correlation. Okay. And can I take 1 from what is left over in my hundreds? And the answer is yes. So we're ready to subtract. So it looks like I need to take 6, 1, 2, 3, 4, 5, 6. Looks like I need to take 4, 1, 2, 3, 4. And it looks like I need to take 1. So I subtracted 146. So now we get to see what we have left over. So I'm able to subtractize here. So it looks like I have 5, 6, 6 ones. I have, let's see, 3, 6, 7, 8 10s, which is equal to 80. And I have 200. And 200 plus 80 plus 6 is 286. And that is how you concretely represent addition and subtraction with base 10 blocks.